find extreme value of the function f of x comma y, which is equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. First take the given problem f of x comma y. Here del f by del x means we have to differentiate f of x comma y partially with respect to x. Hence we have to treat y value as constant. Here differentiation of x power 4 is 4x cube. Here this is 0. The differentiation of minus 2x square is minus 4x. Plus here differentiation of 4xy, here 4y is constant as it is, into differentiation of x is 1, hence we get 4y. Here this value becomes 0, hence we get del f by del x value as 4x cube minus 4x plus 4y. Consider this function as equation number 1. Similarly, del f by del y value is, here we have to treat x value as constant. The differentiation of y power 4 is 4y cube, this value becomes 0, plus here we have to treat x and 4 as constant, 4x is constant and differentiation of y is 1, hence we get 4x minus 2 into y square, differentiation is 2y, hence we get 2 into 2 is 4y. Consider this as equation number 2. After finding del f by del x and del f by del y, to find the maximum and minimum value we have to equate to 0, that is 4x cube minus 4x plus 4y is equal to 0 and 4y cube plus 4x minus 4y is equal to 0. Here we can take 4 as common and that term 4 goes to the right hand side, the equation becomes x cube minus x plus y is equal to 0. Call this as equation number 3. Similarly, for this if we take 4 as common and that goes to the right hand side, that becomes y cube plus x minus y is equal to 0. Call this as equation number 4. Here in previous problems we can easily get the value of x and y directly, but in this equation it contains both x and y term. So to evaluate these two equations we can do this procedure. Here equation 3 is x cube minus x plus y is equal to 0. Equation 4 is y cube plus x minus y is equal to 0. Here we have minus x, here we have plus x, here we have plus y and minus y. Hence to cancel this term, you can add this true term. We get this as, here if we add this true term, the first term becomes x cube plus y cube. Here minus x plus x gets cancelled, here plus y minus y gets cancelled. The remaining value is x cube plus y cube is equal to 0. Understand this procedure. Here to cancel this term, if we can add these two equations, we get as, here first term is x cube plus y cube, here minus x plus x gets cancelled, here plus y minus y gets cancelled, we get the value as x cube plus y cube is equal to 0. Here x cube plus y cube is equal to 0, this is of the form a cube plus b cube. We know that a cube plus b cube formula is a plus b into a square minus ab plus b square. Here we have applied this formula, that is x cube plus y cube is x plus y into x square minus xy plus y square is equal to 0. Here x plus y into x square minus xy plus y square is equal to 0. This implies x plus y is equal to 0 or x square minus xy plus y square value is equal to 0. Here if we take this first term, that is x plus y is equal to 0, hence we can take it as x value, that becomes, if we take y to the right hand side, that becomes minus y. We can easily substitute in the equation 3 or in equation 4, we get the value of x or we get the value of y. I'll show how to find. Here we have considered the equation number 4, that is y cube plus x minus y is equal to 0. Here put x is equal to minus y. In the place of x we have to substitute as minus y, we get as y cube plus of x is minus y as it is equal to 0. Here plus into minus y, here also minus y. Hence we get y cube minus 2y which is equal to 0. Here y cube minus 2y is equal to 0. We can take y as common. We get as y into y square minus 2 is equal to 0. This becomes y is equal to 0 or y square minus 2 is equal to 0. That becomes y is plus or minus root 2. If we take this square to the right hand side, that becomes square root of 2. Hence we get the point of intersection as, here x is minus y. So substituting y value as 0, we get x value as 0. Here substituting y value as plus root 2, x value becomes minus root 2. Here substituting y value as minus root 2, we get the value of x as plus root 2. Hence we get the point of intersection as 0, 0, root 2, comma minus root 2, minus root 2, comma root 2. These are all the point of intersection for the function f of x comma y. Here this step is very important. Here using the value x is equal to minus y, we can substitute in the equation 3 or equation 4, we get the value of y. If we substitute x is equal to minus y in equation 3, we get the value as x. Here we have substitute the value of x equal to minus y in equation 4, we get the value of y as 0, y is plus root 2 minus root 2. If we substitute those values, we get x value as 0, root 2 minus root 2. Hence, the point of intersection are 0, 0, root 2, minus root 2, minus root 2, root 2. After obtaining point of intersection, we have to find ABC value. For that, del f by del x is 4x cube minus 4x plus y. Del f by del y is 4y cube plus 4x minus 4y. Hence, we get A value is here del square f by del x square. We get here we have to differentiate this term partially with respect to x. That becomes 4 into x cube, differentiation is 3x square. Hence, we get 12x square minus 4. This is our A value. Similarly, B is fxy, that is del square f by del x del y. That means you have to differentiate this term again with respect to y. Here this is 0, this value becomes 0. Here 4 into differentiation of y is 1. Hence we get B value is 4. C is del square f by del y square. Here we have to differentiate del f by del y partially with respect to y. We get as 4 into y cube, differentiation is 3y square. Hence we get 12y square minus 4. This is our C. After finding ABC value, we have to construct a table. Hence, we have to construct 4 columns. Here, this first is points A, B, C, AC minus B square, and conclusion. Here, take the points as 0, 0, root 2, minus root 2, minus root 2, root 2. Here, to find the A value means substitute x is 0 and y as 0. Here, this becomes 0. Hence, we get A value as minus 4. That is less than 0. Here, B is 4. Here, no xy term. Take B as it is, that is 4. C value is here, substitute y value is 0, that becomes C is minus 4. Hence, we get AC minus B square as, here A is minus 4, C is minus 4. Hence, we get 4 into 4 is 16, minus B square is 4 square. Hence, we get 4 square is 16. 16 minus 16 is 0. In the similar way, we have to substitute x value as root 2 and y value as minus root 2. We get A value as here 12 into, here x square is root 2 whole square. Hence, we can cancel root and 2. Hence, we get 12 into 2 is 24 minus 4 is 20, which is greater than 0. Here, B is 4 itself. C is, here we have to substitute y as minus root 2. Here, minus root 2 whole square means we can take it as 2 itself. 12 into 2 is 24 minus 4 is 20. Hence, AC minus B square, that is 20 into 20 is 400 minus B square is 16. Hence, we get the value of AC minus B square as 384, which is greater than 0. In the similar way, we have to put x value as minus root 2, y is root 2. Hence, we get A value as here minus root 2 whole square, that becomes positive sign of 2. That is 12 into 2 is 24 minus 4 is 20, which is greater than 0. B is 4 itself. And C is, here we have to substitute y value as root 2. Hence, we get root 2 whole square, 2 and root gets cancelled. 12 into 2 is 24 minus 4 is 20. Hence, we get AC minus B square as 20 into 20 is 400 minus B square is 4 square, that is 16. Hence, we get the value of AC minus B square as 384, which is greater than 0. After constructing ABC and AC minus B square, we have to find the extreme values. For that, take AC minus B square value, which is equal to 0 means we can directly tell that the value is a saddle point. Similarly, AC minus B square value is greater than 0 and A's value is also greater than 0. That becomes, it has a minimum value of a function. Similarly, AC minus B square is greater than 0 and A is greater than 0. That means for the point minus root 2, root 2, we get minimum value for the function f of x, y. This completes the problem.